There are two principal ways in which Bezier curves differ from Catmull-Ram curves. One is in the whole way that we design with the curves. With a Bezier curve, we have points that have handles, and we move the handles around to shape the curve. The other way in which they differ is that the conditions for smoothness are different. In Catmull-Ram curves, all we had to do was overlap 3 points of each new segment with the segment that just came before it. In Bezier curves, the condition's a little bit different, and in this video, we'll see how. Let's suppose we want to draw two Bezier curve segments and we want them to overlap smoothly. Here's our first Bezier curve. We have two knots and two handles. I'll connect them up with lines so it's pretty clear which handle goes with which knot. And here's the Bezier curve that this set of 4 points would generate. Now let's imagine a second Bezier curve, 2 points and 2 handles, we'll connect them up in pairs, and here's the curve that this would generate. Now I would like these two curves to join together smoothly. That means at a minimum, one of them has to move so that they at least touch, and then one of them has to change so that they're smooth. So let's move the green one so it touches the orange one. Great, so now the first point of the green curve is the same as the last point of the orange curve. Great, so now the two curves touch. The big question now is, how do we make a smooth blend from the orange curve to the green one? So the first question is, which curve do we want to change in order to make them smooth, the orange one or the green one? And I'll keep the orange one in place, so I'll change the green one. Now the question is, what do I want to do to the green one? There are lots of ways to make these things line up smoothly. The easiest way is to leave the last point of the green curve, the point and the handle that's on the right, alone. We won't touch those. All we'll change is the handle of the first point on the curve, reshaping the curve. So let's do that. If I move the first green handle down to here and redraw the curve, we get this. And these two curves join together smoothly. So where did I move that green handle? How did I know where it needed to go in order to make these two curves join up smoothly? Here's the technique. Here are all of the points once again, and in black I'm showing you the last handle of the orange curve, the last point of the orange curve, which is also the first point of the green curve, and the first green handle. Notice that these 3 points all lie on a line. That's the first condition. The last handle of the orange curve, the shared point, and the first handle of the green curve all lie on the same line. That gets us half the way there, but there's one more condition. The other condition is that the distance from the handle to the point along the orange curve has to be the same as the distance from the handle to the point along the green curve. As long as these two conditions are met, that the 3 points lie on a line and their distances are equal, then when we draw the two curves, they line up smoothly. And this rule comes to us from the underlying mathematics. There's really no reason to get into why that's the rule. Just remember, that's the way it has to be. So let's look at how to make this happen. One way to think about this is to draw a little box from the last handle of the orange curve to the last point of the orange curve. We can use this box to find the green handle just by drawing it in this position. So these two boxes share a corner at the shared point, and their diagonally opposite corners are the handles. So let me show you how you might write a little bit of code to actually pull this off and put the green handle right where you need it to get a nice, smooth transition. Here are our two curves again, and I've labeled the points so we can refer to them. The orange curve has points A, B, C, D. The green curve has points E, F, G, H. What we want to find is this box, from the handle C to the point D. Well, the box has a width, let's call it W, and a height, let's call it H. To find the width, all we have to do is compute dx minus cx. That's the difference between the x component of point D and the x component of point C. It's just the horizontal distance between the 2 points. That's the width of the box. By the same token, the height of the box is just the difference in the y values. dy minus cy. So now we know how to find the width and height of that box. Let's now use that box to get these two curves to line up together smoothly. My strategy will be to move the point E so it's sitting on top of D. That way the two curves touch. And then I'll move point F so that everything lines up smoothly. So let's go ahead and do those two things one at a time. First off, we'll move point E so it's sitting on top of point D. The easiest way to do that is to just say the x component of E is the x component of D. That moves E horizontally, so it's got the same x value that D has, and then I'll say the same thing for the y component. So now E and D have the very same coordinates. Their x values and y values are identical. That's great because now we have the two curves touching. All that's left to make everything smooth is to move F. Now, how much do we move F? Well, remember, if we can find this box from C to D, and we know how to find that box, we'll draw the box again at point D or E, it's the same thing, and the bottom right-hand corner is where F wants to go. So let's find the x coordinate. The new value of F, Fx, is the x value of E, that's the left side of the box, and we could have used D as well since they're the same thing, plus the width of the box. And the width of the box is just the difference between dx and cx. Once we've made this assignment, things look like this. We're getting very close, but we're not quite there yet because we want F to be right smack on the bottom right-hand corner of the box. To do that, all we have to do is move it in Y. The bottom right-hand corner of that box in Y is the Y value of E or the Y value of D, they're the same thing, plus the height of the box, which we found before is dy minus cy. Once we assign this value to Fy, F moves here. Now F is sitting on the bottom right-hand corner of the box. When we draw these two curves with E and F now in position, they come out smooth. The link between them is as smooth as can be, and everything will look beautiful. Of course, if you want a sharp corner there, you can get that. Just don't move F in this way. But most of the time, you're going to want things smooth, and this is the way to achieve that. You can also do this for big bunches of curves. Suppose that we have these three curves, and we want to join them up smoothly. The first thing I'll do is I'll move the orange curve so that it touches the beginning of the green curve. And now, just for fun, for variation, instead of moving the first green handle, I'll move the last orange handle. So remember, I'm going to want the last orange handle, the shared point, and the green handle to lie on the same line, equal distances from the shared point. When I do that, and I redraw the curves, everything is smooth. Now let's join up the green curve and the purple one. I'll move the purple one up so that the two curves touch, and now I'll move the green handle so it is lined up with the purple handle and the purple point, and it's the same distance away from the shared points. And when I draw the curve with the handle in this new position, I get this, and everything is smooth. So this is the technique for joining up little pieces of Bezier curves so everything comes out smoothly. I grant you, it's a bit more work than we had to do for the Catmull-Rom curve, and that's really the trade-off between the two curves. The Catmull-Rom curves are really easy to line up smoothly, but the individual segments of a Catmull-Rom curve can't make things like this S shape in the green curve or the loop in the purple curve. To make those, you need to use lots more points. The Bezier curves let you make these shapes with a smaller number of points, but you have to go through a little bit more work to make everything line up smoothly. In the next few videos, we'll see the mechanics for creating and manipulating these kinds of curves inside processing.